You are listening to the Gable Media Continuing Education podcast feed, the most entertaining and convenient way for AEC professionals to get continuing education credits, including AIA-approved courses. As a Gable member, just listen and follow the link in the show notes to take a brief quiz and obtain your credit today. Enjoy.
So we're taking Ethernet cables, standard Ethernet cables that you use for cameras, to power access points, to power your IP phone in your desk. And we're using that same cable and same infrastructure to now power other things in the building. So things I'm talking about is the lighting. So instead of having typical NC cable going to lights, now we have Ethernet cables. Motorized window treatments. We're working with some of our partners to manufacture HVAC units and televisions on PoE. So a typical television, you already have to drop one Ethernet and you have to bring one power circuit. Now, or soon, you can do one Ethernet cable for power and data both. And we want to do that same thing for basically everything in the entire building.
Hello, my name is Demetrius, and you are listening to Spaces Podcasts. All right, this is a super fascinating conversation. I spoke with Hannah Walker. She's the Chief Operating Officer at Sinclair Digital. We discussed this new technology that I had just heard about for the first time recently. Spoke with her for another podcast called Detailed. And in that conversation, we focused on a hotel that she happened to work on and provide a lot of technology for. So I invited her here to go a little bit deeper into some of the technology that they're working on at Sinclair Digital. Talked about energy storage, digital electricity, which is also another new thing, and power over Ethernet, which is one of the main ones that I wanted to get to. Super fascinating conversation. This is one of those conversations that I think you should probably listen to twice. Not that it's complicated, but I definitely picked up on more things the second time around. One thing to note is that I realized we did not specifically define low voltage, which we talk a lot about in the conversation. So low voltage systems are defined as anything under 50 volts. So that's like doorbells, garage door opener controls, heating and cooling thermostats, alarm systems and sensors, and things like automated curtains and those types of systems. Now, as a precursor, just to give you a little insight into where this conversation is going to go, we talked about transitioning some electrical components that are currently on high voltage to a low voltage system. So a lot of this technology, as far as digital electricity and power over Ethernet, can handle that. Again, we talked about the power over Ethernet, what it is, its limitations, touched on the Hotel Marcel, which is covered in greater detail in that detailed episode. We got into DC microgrid systems, and Hannah breaks down the energy flow process of AC and DC. So make sure to check the show notes. I'm going to put a lot of contact information there, because I know you're going to want to contact Sinclair Digital after this. So you can check for that information there. So before we get too far into it, if you can step back and tell our listeners a little bit about yourself and a little bit about Sinclair Digital.
Sure. So as you mentioned, I'm the Chief Operating Officer at Sinclair Digital. So I handle all of our projects from design all the way through commissioning. And we work in construction as we worked at the Hotel Marcel. So my background, I actually started in architecture. I was an architectural major at Texas A&M. And then I ended up meeting a developer. He was developing luxury hospitality, and he was looking for an in-house architect to help him with interior design, design services, working with their architect and construction team, and be his, hands and feet on the site, which gave me so much experience learning about what goes into a project from A to Z. As a developer side, you are concerned with everything in the building. And he specifically wanted to look at using different types of technologies in the building that weren't really utilized before. And so that's where the Sinclair Hotel came into play, and that's where our namesake Sinclair happened. So that's our first project that we sunk our teeth into and really redesigned the electrical infrastructure into transitioning as many components from high voltage AC to low voltage DC. And that's where Sinclair Digital spun out of. And so at the Hotel Marcel, we were hired as the low voltage designers from everything from the traditional low voltage. So their, wireless access points, their phone system in the guest rooms, typical stuff that is in every hotel. And then we additionally designed all of the lighting and all of their motorized window treatments to also run off of low voltage DC as well. So all of those factors are all running off of Ethernet cables instead of a traditional high voltage AC system. So that's our role that we played at the Marcel Hotel.
Yeah. Did you do any, did you work for an architecture firm prior?
I worked for an architecture firm in my summers of college and in the winter breaks as well in Wichita Falls. So, I did get a decent amount of experience learning what it's like to work in an architecture firm.
Yeah.
And especially when you work at the bottom, you're doing a lot of grunt work. It's not what you learn in school, is what you're doing. So I found that working with a developer was so much more fast paced, and you're actually the decision maker when you work for the developer.
Yeah.
At school, you're always the decision maker, right? It's your design, your building. But when you go into the real world, you're completely at the dictation and the whim of your clients because it's their money. Yeah, it was a very interesting transition, I will say. And I think working through the developer was a good transition because if you would have just gone straight from architecture to networking, it would have been like throwing cold water around yourself.
Yeah.
But I still got to do a lot of architecture and interior design, working with the developer. We actually changed interior designers for a restaurant mid-project. So we had to do the entire design from scratch. So we hired a new designer who did the concept plans, just like very conceptual, like this is what it should look like, rough, layout. And then myself and our other in-house architect did the entire rest of the drawings, picked out every finish, and then, did the RCPs and oversaw the construction. So we really got to do still a lot of things in our educational field. And then slowly and surely, I got more education in networking, low voltage. Got some certifications, got some training. Now I'm pretty much solely focused on the technology low voltage side.
Yeah. So as a technology designer, how do you describe what that role is exactly? Like what's your day-to-day or what does a project or your process through a project look like?
So typically an owner hires us because they are interested in sustainability. They're interested in technology and they have some type of goal in the project with controls of some sort, right? They want to have a great guest experience. They want to have, luxury touch points throughout the facility where everything's talking to each other, mobile application. So we meet these owners typically, and right now we call them unicorns, right? Because they have to have the right mix. Some developers are just worried about bottom dollar. They don't want to have risk with newer types of things. They want to do the cheapest thing possible, and they don't want to have any new type of technology, right? So those are not the clients for us. So it has to be the client that's interested in the environment, has sustainability goals, and is willing to try something new for the betterment of their project, right? So a lot of times it's people that are not flipping the building, right? They're going to own and hold the building because they're also interested in operational costs and operational efficiencies. So anyway, we get hired in the project and we immediately integrate with the design team. So just like any other design team contractor, the architect, we're hired usually directly with the architect or the owner. They share their Revit model or their plans, whatever the project is using as their system. And then we start laying out our own drawings. So for a hotel, for example, they usually do a pricing set after the schematic design. So we'll lay out, a single guest room, all the, bells and whistles, all the features in low voltage drawings. We say, this is how many data drops, this is how many Ethernet cables. And we kind of do a very basic skeletal system that can then be sent out for pricing. So we really operate just like any other electrical designer, mechanical designer, and we just fit right into the project team. So at that point, when we're meeting the other design team members, that's when we start to talk about, okay, typical MVP designer, you don't need to design the lighting circuit. That's going to come off. That's going to go on our drawings. And we really start to work out, what's in Division 26, what's in Division 27, how are we going to hire this out? It's a lot of coordination with the GC, the electrical engineer, and the lighting designer at that point to make sure everything's starting to get separated into their different buckets.
Yeah. Is it very much different than a typical IT type of designer? How and if it is different, how would you sort of highlight those differences?
So it's very, very different than a typical IT designer. One thing I'll say is that a typical IT designer will come in much later into the project because all of that infrastructure is not considered main core building infrastructure. It's usually an overlay on top. And so, some architects or some owners don't even hire their low voltage designer till the very tail end. And then they just come in and they just put their drops around everything else.
Yeah.
They're also not typically involved that much in the construction process. For example, the phone system, electrical engineer sometimes even just does it. They just lay out a couple data drops. The contractors pull them back to a closet. And then when everything's finished, that low voltage installer will come in, bring their switches, and upstart the equipment. So the integration and construction is much more heavy when you're doing PoE, lighting, and shades because you are part of the infrastructure. The second thing that's very different is the fact that lighting and parts of lighting are considered a part of the life safety systems. So now you are designing things that are UL 924, which is part of life safety system. So when the power goes out, you have to have egress pathway. That all has to be coordinated much more carefully with the electrical engineer, what's backing up these systems. And it's not just, data that if it goes offline, inconvenient, but no big deal. Now we're dealing with designing life safety systems, which is much more regulated and much more important to have all your ducks in a row for.
You mentioned PoE. Can you explain what the PoE technology is?
So PoE is one of the technologies that we deploy a lot. It's one of our very core technologies that we focus on. So it stands for Power over Ethernet. So we're taking Ethernet cables, standard Ethernet cables that you use for cameras, to power access points, to power your IP phone, your desk, and we're using that same cable and same infrastructure to now power other things in the building. So things I'm talking about is the lighting. So instead of having typical NC cable going to lights, now we have Ethernet cables. Motorized window treatments. We're working with some of our partners to manufacture HVAC units and televisions on PoE. So a typical television, you already have to drop one Ethernet and you have to bring one power circuit. Now, or soon, you can do one Ethernet cable for power and data both. And we want to do that same thing for basically everything in the entire building.
Wow. Are there any limitations to the PoE technology?
Yeah, so the typical limitations that go around PoE is its power over Ethernet is considered class 2, which means that it's low voltage. So to qualify as low voltage, it has to be below 60 volt DC, and it has to be below 100 watts of power. So a typical, they call it PoE++ now because it started, traditional PoE is only 15 watts. And then it went to 30 and it went to 60. Now it's at 90, which is really going to be the cap because now we're hitting that, 100 watt limitation. So anything over 100 watts is out of the realm of power over Ethernet. That's when you start to look at other types of low voltage DC systems that can power those things, but can peak higher than 100 watts. Another limitation is distance limitation of 325 feet from your endpoint. So you have to consider that when you're laying out your infrastructure, how far away your device is, how far away can I be from them? And those are the two main limitations. It's the power and the distance.
Got it. Any other special considerations, either for the architect or maybe electrical engineer, as far as install or design in general?
The main limitations or changes, I should say, I wouldn't call them limitations, is depending on the design, you're going to have to house this network equipment somewhere. Today, you have electrical circuit panels, right? And they're in the electrical room, and that is the backbone of your electrical system. So with using PoE, now you have network switches. Those are either going to be, rack mounted in a central location. So you'll have like, IT closets spread throughout the building, one location, depending on the height of the space, etc. We like to deploy a distributed switch system. So now we have switches located in ceilings, behind access panels. So you can basically eliminate IT closet by distributing the power throughout the building more evenly. But again, consideration for the architect. Where are the access panels? How are they accessed? Where are they hidden? That's the stuff you kind of have to coordinate with your architects. And what's the best decision for the client? If it's like a 1-story small building, just put them in a rack in your IT closet, it's fine. But, you get some advantages by distributing it out. If you can save space, you don't have to have all those, BTU calculations for your IT rooms. You can get that space back and have revenue generating space. So there are a lot of, pros and cons for both ways to do that.
Yeah. What's the space necessary when you do that distributed for each panel? What are you looking at size wise?
So depending on how you deploy, you can group switches together. You can have them separated. We in our hotel at Sinclair, we ended up putting one single switch in every closet in the guest room. So just the millwork, we just had a small like 2x2 part of the millwork just blanked off, so you couldn't see it, and it really didn't affect the room operations at all, and it really didn't affect having to have access panels because it was already there. It was going to be built in anyway. So that was very easy. But, if you want to do it in ceiling, you need some sort of access, depending if you have 1 switch or 3 switches, maybe you're on a 2x2 access panel would cover you. And Hotel Marcel, the developer, was actually an architect as well, which is interesting because typical developers don't really care that much about certain things.
Yeah.
But when you're working for an architect, they care very much about making sure everything's in line. And his thing was no access panels in the guest room at all. Not the bathroom, not the main room. He hates access panels, hates them with a passion. Even HVAC, everything was accessible from in the room, like not a single access panel in this project. So, obviously there's access panels, but it was very particular in the room. So that was not going to be an option for us. So we always go with what's the best decision for the clients at the end of the day.
Yeah. Yeah. This is such a fascinating technology, and the approach that you're taking. I know you guys have a few other systems that you install, particularly I think on Hotel Marcel, you contributed basically to a mini grid or a grid system for that hotel. Can you talk a little bit about that and some of the other systems that you provide?
Right. So I'll tell you about the Hotel Marcel. So it's an amazing project. Their goal was to have a net zero property. So they're generating as much power as they're going to use on site as they consume. And so whenever they realized that they were going to have renewable energy and they wanted to store that energy in batteries, those are both DC systems as well. So now we can start to get into the realm of building a building as a DC microgrid. Because when you're going to use renewables, typically what happens is you get the panels or you get the turbine, all that energy is generated in DC, direct current power. And then to transport that energy, you usually have to go back to AC to transport it to the building. And then if you're storing it in a battery, then it goes back to DC to go in the battery. And then when you deploy it out of the battery, same thing, goes back out to AC and then comes back to DC when you power the LED at the end. And so one thing that we tried to do at Marcel was remove as many of those AC to DC efficiency losses by deploying technology that sends DC power, like the PoE, for example. And another technology that we were looking at was called digital electricity. So it's a new type of energy. It's fault managed power. It's going to be classified as class 4. It's already passed in the NEC code review, and it's coming out in the 2023 new electrical codes. And class 4 power, like we mentioned, fault managed power, is essentially pulsing packets of DC energy. You can pulse it up to 700 pulses a second. And so that's a way you can send DC power a long way. So if we go back, to the Tesla versus Edison discussion, AC versus DC, how do we power buildings? We ended up going in an AC direction because you can't send DC power long distances safely. It's too much power. So that's why they went with AC power. But now with class 4 power, fault managed power, we can send lots of DC power long distances. So that's what we did at Marcel. So we started taking our larger DC loads and sending it across class 4 power with a company called Volt Server. They make digital electricity. And we started sending power throughout the building that way. Some of the advantages of using these types of technologies is it's all safe to touch. So you can't start fires. You can use low voltage technicians to install it. You're using about 75% less copper. Electrical and copper costs are just skyrocketing right now.
Yeah.
So the fact that you can use thinner wires, it's safe to touch. You can start fires with it. You can distribute it throughout your building without conduits. Is a huge bonus today in construction. And now that you're connecting everything with Ethernet and with low voltage cabling, you're also getting communications on top of that. So we're always trying to figure out, how do we make buildings more intelligent? How do we make them more sustainable? And being able to make those automations, turn off the HVAC, turn the shades off, turn the lights off, turn it back on. All of that is data and ability that's built into these types of systems. So not only are you getting less copper, less metal, safer, you're also getting communications on top. And that's why we're seeing some interest in these types of systems that we're designing.
Yeah. Are you guys the only one, or are there other companies that are taking this approach?
So we are kind of in a unique position for a couple of reasons. There are people that are starting to design and deploy PoE lighting specifically, because that's been around now for 5-6 years, because the switching network infrastructure, starting at 60, going to 90. So people are kind of realizing that this is, cost effective for their projects. The fact that we develop our own projects as well is giving us the buying power, one, and also the ear of manufacturers to make new products that work with this type of system. So we're very close partners with LG. So they're making us TVs. They're making us HVAC units. We're very close to partners with Kohler. So they're making us shower valves that run off of an Ethernet cable. There's nobody else that is doing that type of work, that type of R&D work that we're doing. And so we have the combination of the design experience, because we own our own properties that we put this technology in. And we have the manufacturing contacts to make new products that are going to be on the market for everybody to use. So we kind of see ourselves as an early pioneer of this type of technology. And we want to build products and software for everyone to design into their own projects. We don't want to design, for forever. We're just doing it to get the technology out there, to get the components out there, and, build all these systems that we can now, sell and bring to market to everybody, that wants to design these types of systems.
Yeah. Wow. This is such an exciting innovation. So I'm rooting for you guys and look forward to watching you continue down this path. For those that are interested in following along and learning more about Sinclair Digital, what's the best way to do so?
So, they can reach out to me directly. We're on, LinkedIn. We're always speaking at conferences. So we have, people on the boards of NECA, which is the National Electric Code Board. We're speaking at low voltage conferences too, like Bixie. So, you can easily catch us at one of those, or reach out to us on our website, or, just email me directly. We're still a small enough company to where we kind of do a little bit of everything, right? So, we're happy to take information from anybody. And, if you have a project that you're interested in looking at cellular technology, we'd love to chat with you.
Do you want to give out your email?
Yeah. It's just Hannah, HANNAH, at sinclair-digital.com.
Okay.
And then our website is just sinclair-digital.com.
All right. Thank you so much, Hannah. I will link all that stuff, and including that episode, on the the detailed episode on the Hotel Marcel project, all in the show notes. Thank you so much again, Hannah, for joining me and sharing this information. Thank you to the listeners for listening. We will talk again on the next one. Thanks. Thanks again for listening. Spaces is part of the Gable Media Network. You can check out similar content at gablemedia.com. That's GABL media.com. If you enjoy our show, you can support us in 3 simple ways. You can leave us a rating and review on Apple Podcasts or on your podcast app if it allows you to. Tell a friend and follow us on social media. Thanks for spending time with us.